Okay, so we have difference quotient, which is just the rate of change of a function from x to x plus h. So the change in delta y is f of x plus h minus f of x, and the change in x is just h. This is called difference quotient. And as I said, we have instantaneous rate of change. Which is just the limit of the difference quotient when h goes to 0. So it's the limit of f of x plus h minus f of x divided by h as h goes to 0. So for example, let's say that f of x is equal to so these are difference quotient, and the instantaneous rate of change is just the difference quotient when h approaches 0. So the limit of the difference quotient when h approaches 0. So let's say that f of x is 5x squared plus 1. Now I want to find the instantaneous rate of change. What is the instantaneous rate of change? Is the limit of f of x plus h minus f of x over h as h goes to 0. So this is the limit of 5 times x plus h squared. Maybe let's do this. This is the limit as h goes to 0 of this is f of x plus h, and then f of x is just 5x squared plus 1 divided by h. Right? Now, what is x plus h squared? X or 5 times x plus h squared. X plus h squared is x squared plus h squared plus 2 times x times h. So this is just 5x squared plus 10 times xh plus 5h squared, and then plus 1. When you subtract 5x squared plus 1, you get 5x squared minus 5x squared is 0. So you have 10 times xh plus 5h squared divided by h. H goes to 0. Okay, which is equal to, if you simplify this h with h, and then so you get limit of h goes to 0, 10x plus 5h. Now when h goes to 0, you get just 10x. So the instantaneous rate of change for this function at x is 10x. Let's do another question. We want to find. Yeah. So let's say that f of x is 2 times root x. Then we want to find the instantaneous rate of change, which is just limit of f of x plus h minus f of x divided by h goes to 0. So this is equal to 2 times the square root of x plus h minus 2 times the square root x divided by h. And then you have to take the limit h goes to 0. Now, if you multiply the top and the bottom by square root x plus h plus the square root x, so if you multiply the top and bottom with square root x plus h plus the square root x, so on the top, and there is also 2, sorry. Yeah, there is 2. So on the top, you have x plus h minus x. Two times x plus h minus x. And then at the bottom, you have h times square root x plus h plus square root x. So on the top, you have 2h. And the denominator is h times the square root x plus h plus the square root x. And the h is gone. Now, when h goes to 0, you see x plus h just becomes x, right? At the denominator. So when x goes to 0, you get 2 over 2 times root x, which is 1 over root x. So the instantaneous rate of change for this function, 2 times root x, is just 1 over root x.
Can you explain the step where you get from 2h to 2 over 2 square root of x? Can you see that part again?
Yeah, because so at the denominator you have the square root x plus h plus the square root x, right? This is maybe I just write it a bit. Right? So when h goes to 0, you have square root x plus the square root x, which is 2 times the square root x. Hmm? No. Okay. Okay. And by the way, something interesting here is that, I mean, about the limit is not a part of this course, but I just want to tell you, it's good for your own knowledge. So here, you have limits which are called indeterminate limits. So for example, look at this limit. Look at this limit. So you see, on the numerator, when h goes to 0, numerator just is 0 because it's root x minus root x, right? Denominator is also 0 when h goes to 0. So you have 0 over 0. So these are called indeterminate forms or indeterminate limits. And which is the same as here. If you look at this limit, you see the numerator, when h goes to 0, the numerator is just 5x squared plus 1 minus 5x squared plus 1, which is 0. Denominator also 0. So when h goes to 0, you have 0 over 0. Again, indeterminate limits. But 0 over 0 is not always equal to 0, or it can be a number, like here you have 10x, or the other one you have 1 over square root x. Because we basically simplify and determine the limit. Okay, so these are just two examples of instantaneous rate of change. Again, the instantaneous rate of change is just the difference quotient when h goes to 0. Now I want to solve some problems about characteristics of functions. Imagine that f of x is equal to the square root x minus 1. So the question is, find the function gx such that part A, f of x times g of x equal to 3x. Part B, g of f of x equal to 5x plus 1. And then part C, f of g of x equal to 5x. So to do part A, it's easy because when you have f of x times g of x equal to 3x, that means g of x is just 3x over f of x, right? We have f of x times g of x equal to 3x. That means g of x is equal to 3x divided by f of x, which is 3x. Hmm? No, that's just g of x. So part A is straightforward, but maybe part B and C are more tricky. Let me do C first. You want to find the g of x such that f of g is 5x plus 1. So f of g of x is 5x plus 1, right? But what is f of g of x? F of g is just square root of g of x minus 1. F of g, because f of x is square root x minus 1. So f of g is a square root g minus 1. That means the square root g minus 1 is 5x plus 1. Therefore, gx minus 1 is 5x plus 1 squared. So that means gx minus 1 is 5x plus 1 squared. So g of x is just 5x plus 1 squared plus 1. So g of x is just 25x squared plus 10x plus 2. Okay. Now for part B, you want g of f equal to 5x plus 1. So for part B, you want g of f of x equal to 5x plus 1. But remember that f of x is square root x minus 1. So g of square root x minus 1 is 5x plus 1. So let's say that the square root x minus 1 is t. So that means x minus 1 equal to t squared. Therefore, x is t squared plus 1, right? So that means g of t is 5 times. Remember that here we got x is t squared plus 1. So it's 5 times t squared plus 1 plus 1. So it's 5t squared plus 6. That is g of t. So g of t is 5t squared plus 6. Pardon me? Now imagine that I want to do the same question with this function. Let's say that f of x, assume that another question, similar question. Find the function g of x so that f o g of x equal to 3x minus 5 and g o f of x. So for part A, think about it. I give you some time to do it. Okay. Another question is that, let's say f of x equal to ln of 1 minus x divided by 1 plus x. Show that for any x1 and x2 between minus 1 and 1. And here, when I say between minus 1 and 1, because minus 1, this interval is just the domain of this function. You see the ln of 1 minus x over 1 plus x, its domain is the numbers between minus 1 to 1. So that's just to mention that is the domain. But the important thing is to show that for any x1 and x2, f of x1 plus f of x2 is equal to f of x1 plus x2 divided by 1 plus x1 times x2. Okay. So in order to prove this, you can compute both sides basically. Or you can begin from one side to get the other one. Or you just at the same time, you can compute both sides and reach to the common expression. So what is f of x1 plus f of x2? I want to show that this identity is true for any x1 and x2. So let's compute f of x1 plus f of x2. So this is ln of 1 minus x1 over 1 plus x1 plus ln of 1 minus x2 over. And ln of a plus ln of b is ln of a times b. So this is just ln of 1 minus x1 times 1 minus x2 divided by 1 plus x1. Now I want to compute f of x1 plus x2 over 1 plus x1 times x2. So I want to compute this guy. This is basically the left-hand side. Sorry, the right-hand side. Here, what I wrote in blue is the left-hand side. Now let's look at right-hand side. So that is equal to ln of, so f of x is ln of 1 minus x divided by 1 plus x. So f of this expression is ln of 1 minus divided by 1 plus. So you get on the top on the top you have 1 plus x1 x2 minus x1 minus x2 divided by 1 plus x1 x2 plus x1 plus x2. And and then you can cancel out 1 plus x1, x2 from the both denominators, right? But this is nothing but ln of 1 minus x1 times 1 minus x2 divided by 1 plus x1 times 1 plus x2. Which is exactly equal to the left-hand side. You see, this is the left-hand side.
Identity again?
Yeah, but we want to show that the both sides are equal, right? So let me tell you more details. So this guy, the numerator is just 1 plus x1, x2 minus x1 minus x2 divided by 1 plus x1, x2, right? And then this guy is, you can say similar thing. It's 1 plus x1, x2 plus x1 plus x2 divided by 1 plus x1 times x2, right? You cancel out 1 plus x1, x2. You can factor. 1 minus x1 times 1 minus x2 is 1 plus x1, x2 minus x1 minus x2, right? Multiply, just multiply 1 minus x1 times 1 minus x2. What you got? Okay. Okay. Something similar, just simplifying and working with different functions. Let's say that another question. So let f of x be equal to cosine hyperbolic of x. Remember that cosine hyperbolic is just e to the power x plus e to the power negative x over 2. So show that f of a plus b plus f of a minus b is equal to 2 times f of a times f of b. We are done basically here, but she wanted me to start from the left side instead of going from right to left. We can go from left to right, which is the same thing. So f of a plus b plus f of a minus b is equal to right. Then which is equal to 2 times f of a of b. Is that clear? Okay, now let me give you your assignment. I'm going to write it here, the questions. These are your last assignment. Maybe sorry, I just changed this. So it's you have to compute that limit of the difference quotient. Hmm? Yes. This is question 1.
Okay.
Okay. Then question 2.
Back to the first. Okay.
You wrote it? This is the absolute value of sine x. This is absolute value of x minus 1 over absolute value of x plus. You should do absolutely. I will explain it to you. So, and the last question is, this is FOF, means f of x.
But how to do the question 3?
You have to solve this equation, solve for x. So for example, for A, there are two cases, either sine positive or sine of x is negative. If sine of x is positive, that means sine x equal to sine x plus 1, which doesn't have any solution because sine x cannot be equal to sine x plus 1. So if sine x is positive, there are two cases, sine is positive or negative. If sine x is positive, then absolute value of sine x is just sine x. But this doesn't have any solution because here you have 0 equal to 1. So no solution. So that means you might have solution when sine x is negative. So then you do the same thing when sine x equal to negative. You can take the absolute value and then solve the equation when sine x equal is negative. Absolute value of sine x becomes minus sine x, right? Sine of x is negative, then its absolute value is just minus sine x. But you have to be careful that at the end, you should pay attention to this condition that sine x is negative. Good. So, and these questions are due on Thursday. So tomorrow and Thursday, we are going to review all the units. So we just solve problems.
It can be on Monday.
Hmm?
The final be on Monday.
Final is on Friday.
Can it be on Monday?
Okay.